I've had a request to cover the back side of the classwork and notes that we started on Friday, and to do a few of the problems from the front page of the assigned homework for today. So I'm going to start with number 9, and just reminding you all that with complex fractions, you want to get to a single fraction on the top and a single fraction in the denominator, the bottom, and then just keep flip change. So on number 9, we have x over 3 minus 3 over x in the numerator. So we need to find a common denominator so we can change that into a single fraction before we can keep flip change, because the denominator is already a single fraction. So in order to get a common denominator at the top, we see that we need to multiply that first fraction. It's missing an x from, like if you're getting a common denominator of 3 and x, then it's actually missing the x. So we'll multiply this fraction by x over x. And we'll multiply this second fraction by 3 over 3 because it's missing the 3. So now at the top we would have x squared over 3x minus 9 over 3x. And then that would reduce to x squared minus 9 over 3x. And then that's all over x minus 3 over x. Oops, didn't mean to do that. Because you're just basically keeping that denominator the same in both situations. I thought writing it this way might be a little clearer. So now we have a single fraction on the top and a single fraction on the bottom. So we can keep flip change. X squared minus 9 over 3x. Keep the first, flip this to multiplication, and then change this to its reciprocal. That's going to be, instead of being x minus 3 over x, it's going to be x over x minus 3. Now take a look at what you can factor. This is a special factoring. This is known as the difference of two squares. So that factors to be x minus 3 times x plus 3 all over 3x. And now let's look at what we can cancel. Remember, you can cancel vertically or diagonally. And vertically, we see that these x's cancel. Or, I'm sorry, diagonally, we see the x's cancel. And diagonally, we see that x minus 3 and x minus 3 cancel. So we have a 3 left at the bottom, and we have an x plus 3 left at the top. So that's our final answer is going to be x plus 3 over 3. All right, number 10. On this one, the numerator is a single fraction, but the denominator is not. Oh, hey, Garrett. I had somebody email me and wanted me to do the back side of the notes classwork from Friday and work on some of the problems from the front side of today's work. So I started with number 9 and I'm just jumping in at 10. Is there something other than those that you need to see done?
Well, I mean, I was going to come in here to ask if you were going to record.
Okay, yes.
But like, I don't have anything in particular. I just maybe do a few of them and so I can kind of get a gist of what's going on.
Oh, absolutely. Yes, and I am going to record it.
Okay, great. Thanks.
No problem. I'm going to be, and like I say, the person that emailed me had specifically asked for the back page from the class notes and the example problems that we did on class on Friday, and then the front part of today's work. So that's pretty much, so that'll give you quite a few example problems with some, good variation in it to be able to get the rest. Okay?
Okay, thanks.
All right. Have a blessed afternoon.
Bye.
Bye-bye. Back to number 10. The numerator is a single fraction. The denominator is not. So you need to get a common denominator for the bottom so that you can get the numerator and the denominator to a single fraction, each to a single fraction. So here, with this 1 over p, we're missing a q. So we'll multiply this 1 over p times q over q. Once again, just reminding you guys when getting a common denominator, you're really only multiplying by some form of 1. So it doesn't change the value of it. Okay, so now at the bottom, okay, we'll go ahead and rewrite the top because it doesn't change any. But at the bottom, we now have q over qp, or pq. I'm going to write it that way. Minus p over pq, which that then looks like this. Go ahead and rewrite my numerator. You have q minus p all over p over q. So now we'll keep the first. Flip this to multiplication. And then change this to its reciprocal. So that's, instead of being q minus p over q, it's going to be p over q over q minus p. I just want y'all to know all of that is hard to say. Once again, I just remind you guys that when it's a binomial term like that, it's probably a good idea to keep it in parentheses just to remind yourself that these things don't cancel when there's like addition or subtraction in the middle. That is actually a binomial term. We can see that the PQ cancels, and we're left with a 1 on the top and a Q minus P on the bottom. And so that's my final answer. The numerator on number 11 is a single fraction, so we don't need to do anything there. And then the, hold on just 1 minute, please. We want to go ahead and factor this numerator or this denominator in the denominator in this complex fraction, because what we're going to see when we factor that, if you have a chance to factor something, you want to make sure you're doing that because you want to get the least common denominator. And so you need to have those in factored form to figure out what factors possibly would repeat. So you can see that n minus 4 is repeated in both of these denominators, but we still need a 4 over in that first fraction in the denominator. So you would actually multiply this fraction only by 4 over 4, because this has both the 4 and the n minus 4. So you're only multiplying by what is missing. So this stays the same in the numerator. And over here, you're going to multiply. So you've got 4 times 20, and be 80 over n minus 4 minus 5. Actually, that's 4 times n minus 4. My apologies. Minus 5 over 4 times n minus 4. So we'll keep the top, which is 5 over 4. We're going to change, flip or change. I paused the video, put you all on mute earlier because I thought I was going to sneeze then. And of course, I didn't. Now I'm sneezing. And then I'm going to change this to multiplication. And then 80 minus 5 is 75. But I'm actually going to, I hope this doesn't confuse anyone, but I'm actually going to be flipping this at the same time, because this value is now going to be my denominator. Keep, flip, change. And this is going to be my numerator. 80 minus 5, because this would have been 5 over 4 all over 75. So I kept it, flipped this to multiplication, and then changed this to its reciprocal. That's what that step was. And now I can see what I can cancel. I can cancel the 4s. And 5 goes into 75 15 times. There's a 1 left here. And so now at the top, I have an n minus 4 left, because n minus 4 times 1 is n minus 4. And at the bottom, I have a 15. So this is my final answer for number 11. All right, on number 12, the numerator is a single fraction. It's w over w plus 2. That's just a binomial term. However, the denominator is not. So we need to change it into a single fraction. So we can just bring over the numerator. And what do we need to do to this denominator to get it to be a single fraction? We've got to get a common denominator. So we've got to multiply the top and the bottom by w plus 2. Because 1 is really 1 over 1. So now we have w plus 2 minus w over w plus 2. So w minus w, that would cancel out. Here's my numerator. W minus w, that cancels, and it leaves me with a 2 over w plus 2. So now I'm going to keep flip change, keep the first, keep the numerator just like it is, flip or change that division symbol to a multiplication, and then flip the bottom into a reciprocal. Flip it. So now we're going to look and see what can we cancel out. And we're left with a W on top and a 2 on the bottom. And that's our final answer for that one. Neither the numerator or the denominator are a single fraction. So we're going to have to get a common denominator for both the top and the bottom in order to get them to a single fraction. So we're going to multiply this fraction. It would be missing a b squared over a b squared, and this fraction in the numerator is missing an a squared. So on the left, we'll multiply b squared too close to the top. B squared over b squared. Hope you can see that okay. And over here, that's going to be a squared over a squared, which that will get me b squared over a squared b squared minus, actually, this is what I'm going to do for that one. Sorry about that. I'm going to write it all over a squared because now we have a common denominator. So of a squared, b squared, because you're multiplying these together. So that's going to give me b squared minus a squared at the top all over. And then this is going to multiply. We'll multiply a over a times b over b. So you would have a plus b all over a b. So you'll keep the first, which that's the top one. So you'll keep that. And that's going to be b squared minus a squared all over a squared b squared. Then you're going to flip this to multiplication and change this to its reciprocal. Now, this b squared minus a squared, there's a perfect square in the front and a perfect square in the back. That b squared is a perfect square. The a squared is a perfect square. There's a minus sign separating them. So that's the difference of two squares. And so that can be factored as b plus a or b minus a all over a squared b squared times ab over a plus b. Now, a plus b is the same thing as b plus a because addition is a commutative property. So you can, those are exactly the same thing. So those two can be canceled. And I have 1a in a squared. So that leaves an a down here. And I have 1b in b squared. So that leaves an ab in my denominator. At the top, I have b minus a left. And it's going to all be over a b. All right. Number 14. Neither one of these is a single fraction in the numerator or the denominator, so we need to get them to be a single fraction. This 1 is missing a denominator of n, so we'll multiply it by n over n. And the same thing actually down here in the denominator. This 1 is missing a denominator of n because that would be 1 over 1. So we have m minus n at the top all over n divided by m plus n all over n in the denominator. So now we'll keep the first or the fraction in the numerator. Flip this sign to a multiplication. That big division symbol the big fraction bar is a division symbol. So you'll change that to multiplication, and then you'll flip or change that second or the bottom fraction in the denominator to its reciprocal. see what can cancel. Remember that you can cancel vertically or diagonally. So those two ends cancel out, leaving a 1 in both of those places. And now we have m minus n at the top and m plus n at the bottom. Those cannot cancel. Those are binomial terms, and they cannot cancel. But that's my final answer for that one. I didn't. All right. Number 15 and 16. Neither of those have a common is in the numerator or the denominator is a single fraction. So we need to put a common denominator. In the numerator, we have 1 over 4 plus 1 over 4v. So this first fraction, in order to have a common denominator, it's missing a v in the denominator. So we'll multiply the top and the bottom by v. So that gives us v plus 1, because v times 1 is v. And then this second fraction here will stay the same. And we have a common denominator in the top of 4v. And down here, this one needs to be multiplied by 4 over 4. And this one needs to be multiplied by v over v in order to have a common denominator, because this is missing a 4 and this is missing a v. So 4 times 1 is 4. And v times 1 is v. And we have a denominator of 4v. So we'll keep flip change. So we'll keep the first fraction, which is this whole thing right here. That's the numerator. And it will stay the same. We'll flip this division bar. That fraction bar is a division symbol. It now is going to be multiplication. And then we'll flip the denominator to its reciprocal for v over 4 plus v. Once again, reminding you guys that these are binomial terms. So put them in parentheses to make sure that you don't just accidentally cancel something you're not supposed to. We can cancel diagonally or vertically. So the 4 v's are going to cancel. And we have v plus 1 all over 4 plus v. Nothing else can cancel. So that's going to be my final answer for that one. Number 16. Neither of these have a single fraction in them, so we need to get a common denominator to make them single fractions. But I also notice that this 5a plus 15, something can be factored out of that because there's a common 5 and 15. 5 will go into both of those. So this factors to be 5 times trying to figure out how I can get all of this on the screen. A plus 3, because 5 goes into 5 one time, 5 goes into 15 3 times. So now we see some things that the two of those have in common, and some things that we're going to have to multiply one of the two by. This first fraction, a squared over a plus 3, is missing a 5 in order for it to have a common denominator. So we have to multiply this first fraction by 5. So we'll have 5a squared all over 5 times a plus 3 plus a squared. And then that's all going to be over this one. In order for it to be common, You're going to have to multiply this by 5 over 5, and this side, a plus 3. I know it's getting bunched up here, guys. I'm really sorry. So if I multiply 5 times a, that's going to be 5a. And if I distribute this 1 to a plus 3, that's going to be a plus 3 all over 5 times a plus 3. Now, 5a squared plus a squared. I don't know if you guys noticed that, but we can combine some like terms there. And I'm going to go ahead and I would keep that first one, which I did, and I combined like terms. I'm going to flip this to be multiplication and change this to its reciprocal, which is 5 times a plus 3 all over. And I'm going to go ahead and combine like terms here. 5a and a is 6a plus 3. Now, is there anything we can cancel? And there is. So we can cancel a plus 3. We can cancel the 5s. And it looks like we could factor. Okay, let's just go ahead and write this here. We've got 6a squared all over. And it looks like we can factor a 3 out of 6a plus 3. So let's do that. 3. And that's going to leave you with 2a plus 1. And now we can factor a 3 out of this. Out of the 3 leaves us with a 1, and 3 goes into 6 2 times. So our final answer is going to be 2a squared all over 2a plus 1. So you got to look for all kinds of things that can be factored. So let's take a look at today's work and do a few from that front page. And we can kind of celebrate for a minute because we get a single fraction on the top and a single fraction on the bottom. So all we really have to do for this one is keep flip change. So we'll keep the first is 6a cubed all over 5b. And then we're going to change that to multiplication and then flip this to its reciprocal. So now instead of being 21a over 10b squared, it's going to be 10b squared all over 21a. All right, so let's see if there's something we can cancel. Well, I know that there's a 5b in 10b squared. That would leave 1 on the bottom, and 5 goes into 10 2 times, and b into b squared leaves 1b. And then let's see, here, an a cancels to give me a squared. And 3 goes into both 6 and 21. Goes 2 times there. And 7 times there. So now I have a 2, an a squared, and a 2b. So that's going to give me 4a squared b all over a 7 is left on the bottom. So 2 times a squared times 2b gives me 4a squared b over 7. You can, if you want to, on these. The other way to think about that is to go ahead and multiply that 6a cubed times 10b squared, which would give you 60a cubed b squared all over 105 ab. And then just reduce that down. 15 goes into both of those, which 15 goes into 60 4 times, and 15 goes into 105 7 times. And you could use your exponent rules. A to the third minus a to the first gives you a squared, and b squared minus b would give you b. So there's a couple ways to break that one down. You can either do some of the canceling that we did originally, or if you wanted to multiply it straight out, that's another way to do it, and then reduce from there. Whichever way is easiest for you. Obviously, you get the same answer either way. All right, number 2. Once again, these are single fractions, but I do notice that here on the bottom at some point, I'm going to want to factor because I can see I can factor that 2 out. So let's go ahead and do our keep, flip, change and see where that takes us. 18x squared all over x minus 1. Don't forget, that's a term, a binomial term. So we keep that first numerator fraction, flip it to a multiplication, and then change this to its reciprocal. And while I'm doing that, I'm going to go ahead and factor a 2 out. That's going to be 2 times x minus 1 all over x. So I want to take a look at this and see if there's anything I can cancel. And I see the x minus 1s can cancel. And I know that there is an x left in x squared. And so now I have an 18x times 2 at the top. That's going to be 36x. And I have only a 1 at the bottom. And 36x over 1 is really 36x. All right, number 3. Once again, we have single fractions in the numerator and the denominator. So all we have to do is keep, flip, change. That first one is 4c squared minus 1 over 3c times 9c squared. We're flipping this second one to its reciprocal, 2c plus 1. Okay, something special, and I hope that you all are starting to recognize this. Little more difficult, I think, when there's a 1 as the perfect square, but we need to remember that 1 is a perfect square. So we have a perfect square, 4c squared, that's leading the way of this term right here, and a perfect square, 1 at the back. So you want to make sure that you're seeing things like that and factoring it. That's a special factoring. It's the difference of 2 squares, and it can be factored as 2c plus 1, 2c minus 1. Special factoring. So that's going to be all over 3c times 9c squared all over 2c plus 1. So what do we have that can cancel? 2c plus 1. And then we have 3c. We'll go into 9c squared and leave 3c left because 3 goes into 9 with 3 left over. And there's 1c in c squared, which leaves a c left. So now what do we have left on the top? We have a 2c minus 1 and a 3c all over 1. 3c times 2c minus 1. Just going to erase that. And that is your final answer. Number 4, believe it or not, that's still a single fraction on the top. It's just a trinomial, which I want to try and see if I can factor that. But we'll keep flip change. And while we're doing that, let's think about n squared minus 9n plus 14. Are there two factors that multiply together to give me a positive 14 that when I combine or add them give me a negative 9? And yes, there are. It would be negative 7 and negative 2. If I multiply those together, I'm going to get a positive 14. And if I combine the two of them, I'm going to get a negative 9. I also want to factor this 4n plus 28 because I know 4 goes into both 4 and 28. So if I factor the 4 out, that's going to leave me with n plus 7. And now I've kept that first fraction that was in the numerator. I'm going to flip this into a multiplication problem and then change the denominator to its reciprocal. Don't forget, that's a single term. I can cancel the n plus 7, and I can cancel the n minus 7. And what does that leave me? On the top, I have n minus 2. Remember, that's a term all over 4. So, and that is my final answer. All right. Once again, all single fractions in the denominator and the numerator, but they can be factored. So at the top, I can factor out an 8x. So I'm going to factor, and I'm going to keep flip change in the same step. I sure hope that doesn't confuse anybody. But I'm going to factor 8x out of 8x squared plus 24. So that's going to leave me x plus 3. And then this, once again, that's that special factoring. It's the difference of two squares. Perfect square in the front, a perfect square in the back. So that's a special factoring of x plus 3, the difference of two squares, x minus 3. So that is the numerator factored. So we kept it and factored it. Now we're going to flip or change our division to multiplication and then change this to its reciprocal. And at the same time, we want to go ahead and factor this. 15 minus 5x, that can be factored to be 5 times 3 minus x, all over 2x. Now, I hope you all, recognize that this x minus 3, 3 minus x, that is a negative 1. We learned that way back when we first started simplifying these rational expressions. When you have 3 minus x and x minus 3, that's a -1. That equals -1. Just a reminder of that. And then, so that x minus 3, 3 minus x factors to give me a -1. The x plus 3, x plus 3, they cancel. The 2x, and then over here I've got a 1 left. The 2x also cancels with the 8x, and you got a 4 left at the top. And there's only 1s at the bottom. So let's look, and what do we have left at the top? We've got a 4, we've got a 5, and we've got a -1. So 4 times 5 times -1 is -20. And that's our final answer for number 5. Number 6, once again, we have single fractions. They're deep single fractions, but they're single fractions nonetheless in the numerator and the denominator. So that's the goal. And then we just keep flip change. While we're in the midst of that, though, let's look and see what we can factor out of it. In the numerator, it looks like in the numerator of the numerator, we can factor out 2v, which that's going to leave us v plus 8 all over. And then we've got 2v squared minus 5v minus 7. And I'm going to do that factoring work down here so you can see it in number 8, but this isn't number 8 currently. So that's going to look like 2v squared minus 5v minus 7. I'm going to use the AC method because the person that emailed me is in Miss Wynn's class. So that's what they use. So I'm just reminding you all that that's what I'll be using for this one. So this is -14. So I'm looking for the factors that give me -14 when they're multiplied, and that give me a -5 when I combine them. Well, that's going to be a -7 and a 2. So then we would rewrite that as 2v squared minus 7v, this is going to be weird, plus 2v minus 7. I probably should have written it the other way, but as it probably would have been a cleaner grouping. Let's see what happens. So I can take a 2v out here, and that's going to leave me, no, I can't take a 2v out there. I can take a v out. And that's going to leave me 2v minus 7. And then the only thing you can really factor out of this is a 1. So that would leave me 2v minus 7. So my factors are v plus 1 times 2v minus 7. And then the bottom one, let me erase that. I'm going to keep flip change. I didn't really leave myself a lot of room to do that. So here, I guess I'll just do this and keep flip change in a different step. I I can factor out a 4, and that's going to leave me v squared plus 7v minus 8 all over, and I can factor out a 10, and that's going to leave me v squared minus 1, which I hope y'all recognize that's going to be perfect square. A lot of factoring in this one. Because now 2v times v plus 8 all over v plus 1 over 2v minus 7. Keep it. Flip. And while I'm flipping, this is that bottom fraction here, guys. I'm going to take 10 and I'm going to factor this special factoring pattern, which is the difference of two squares, this v squared minus 1. It factors to v plus 1, v minus 1, all over 4 times, and then v squared plus 7v minus 8. What two factors multiply together to give me a negative 8, when I combine them, give me a positive 7. That's going to be v plus 8, v minus 1. So now I can look for things that I can cancel to get my final answer. A lot of factoring there. So great practice on factoring. We had the difference of two squares, all kinds of things. So it's really good. Let's see. We've got a v plus 8 here. And we've got one diagonally. We've got a v plus 1 in the bottom left corner and a v plus 1 in the upper right. Vertically, we have a v minus 1 and a v minus 1. So now let's take a look at what do we have left. Let's see. 2 will go into 10 5 times. 2 will go into 4 2 times. But now I have a 2 vertically, so that will cancel. So what do I have left? Let's see. On the top, I have a v and I have a 5. And on the bottom, I have a 2v minus 7. So that's going to give me a final answer of v times 5, or 5v, all over 2v minus 7 as an answer for that one. A lot of crazy factoring in that one. Great practice on factoring. Awesome. All right, number 7. We have a single fraction in the numerator, but not in the denominator. So we need to get a common denominator on that one. And in order to do that, this first fraction is missing an x. So we'll multiply the top and the bottom, or we'll multiply that fraction by x over x. And the second fraction is missing a 4. So we'll multiply it by 4 over 4. So that's going to give me x squared over 4 all over. And then we've got x times x squared. That's going to be x cubed minus, and then 4 times 4 is 16 all over 4x. So now we've got them in a single fraction in the numerator and the denominator. So we'll keep the first, flip it to multiplication, and change the last one to its reciprocal. See if there's anything we can cancel. And there is. We can cancel the 4s. But that's it. So that's going to leave me with x squared times x, which is going to be x cubed because you just add the exponents, all over x cubed minus 16. Big note of caution here. This isn't the difference of squares because it starts with the x cubed, and those two x cubes cannot cancel because x cubed minus 16 is a single binomial term, which cannot be canceled with just an x cubed. So this is your final answer. All right, number 8, and the last one for Math Lab today. The denominator is a single fraction. The numerator is not. So we'll have to get a common denominator for the numerator by multiplying this right here by a minus b over a minus b, because this one is really the same as 1 over 1. So that then will be a minus b minus a, which means my a's are going to cancel. And that's going to give me minus b in the numerator of the numerator fraction, all over 1 minus a minus b. So now I'm going to keep the first, or the top fraction, flip this to multiplication, and change that bottom fraction, or a fraction in the denominator, to its reciprocal. Let's see what we can cancel. Looks like we can cancel diagonally an a minus b, and that leaves us with a negative b on top and a 1 on the bottom. So that means that would be negative b over 1. So actually anything over 1 is itself, so the final answer is negative b. And that is it for Math Lab today. I hope you guys were helped by it. If you have any questions, please feel free to email Miss Wynn or myself. Have a blessed evening. Bye-bye.